Welcome to solverfy.
This is the answer to Chapter 15, problem number 52 from the Smith Organic Chemistry textbook. And this problem is asking us to draw all of the isomers that would be formed from the chlorination of 2-chloropentane. And so for A, I've drawn 2-R-2-chloropentane. And then I've drawn the 7 possible products of chlorination, monochlorination, and I've labeled them A through G. So then for part B, we're asked if we were to use a physical separation method, so perhaps fractional distillation, how many fractions would we get? The answer is we would get 7 fractions, since each of these 7 products has different physical properties. There are none of these that are just enantiomers of one another. They are all diastereomers or completely different molecules. And so none of them should appear in the same fraction. They should all be separate. Lastly, we're asked which of the fractions would show optical activity. And so A, B, D, E, and G are going to show optical activity. And we'll take a look at the 2 that are not going to show optical activity, which would be C and F. And so C is a mesocompound. If you were to draw a line right through the central carbon, the half of the molecule to the left and the half of the molecule to the right are exactly the same. And since it is a mesocompound, it doesn't exhibit optical activity. The reason that F does not exhibit optical activity is because F is achiral. There's no carbon in molecule F that has 4 different bonds in it. The carbon that is the first stereocenter in every other molecule pictured here has 2 chlorines on it. And so since it has 2 of the same bond, it doesn't have 4 different bonds. And since it doesn't have 4 different bonds, it is achiral. And since only chiral molecules exhibit optical activity, F does not. And that is the answer to Chapter 15, problem number 52.